Hi, I'm going to talk about the Oud project, where I'm with it, and what my next steps are. So, Oud is a beautiful Arabic musical instrument. Um, it precedes the lute, the European lute. Oud is spelled O-U-D. You can look it up online. Lute, L-U-T-E. Um, And I enjoy playing the oud. And recently, very recently, I decided that I'm going to give it a shot and try and make one based on a specific design with some variations. My background is in engineering. I've been making things. I'm very new to recording videos. So it makes me extremely uncomfortable. But there's two reasons I'm recording. Reason number one is for my own benefit, um, in from different aspects, right? One being that it helps me log my progress and what I'm doing, and I don't have to obviously put it online. So the related second reason is I'm hoping that uh, somebody out there, if they see my video and if it inspires them to make something, um, or they get something out of my video that I'm posting, that would be awesome. Now, my background is in engineering, right? So, fairly comfortable with metals, with, engines, motors, computers, coding, electronics, but I have not worked that much with wood, right? So this is certainly building a musical instrument which requires the highest, in my view, the highest form of craftsmanship using wood. Uh, it's a challenge, um, and I appreciate it. I respect it. Uh, in the last couple months, I have built. I want to think I built fairly, you know, rapid skills using hand tools and wood. There's still a lot to learn, but I think based on where I am, uh, I'm comfortable, right? Obviously, I'm not afraid to make mistakes. Not obviously, but I'm not afraid to make mistakes. And I will make mistakes, which is okay. It's a learning process. As long as you can learn from your mistakes, uh, there's forward progress, right? I got a small shop. It's just room, uh, a small room, not a large room, right? I don't keep my bandsaw in here. My bandsaw is outside. Um but most of the work that I do, I do it in this room, right? Now let's go back to talking about the OOTH project. And I will post as much details, not only what I'm doing, but more importantly, all the resources and all the research that goes behind it. It's not an easy project, right? Uh, there's not too much information available online on the OOD in terms of the construction and the build and the entire process, the details, right? You will find information that is in Arabic. I don't speak Arabic, so I struggle, right? Um, but there is a lot of information on lute, L-U-T-E, right? Uh, I'm in communications with a couple of luthiers, professional luthiers. I'm not a professional, right? So that's why, I have posted or I've documented on my channel, you know, I would be honored if somebody is watching these videos and getting something out of it. But I'm not a professional. I'm not here to teach per se. Like I said, I hope I can inspire somebody. I say I'm not a professional because nothing I do here, right? This is not my uh, day-to-day work which pays my bills, right? So this is just on the side, and anything I do here, uh, I don't, there's no commercial aspect. So therefore, I'm not a professional, and therefore, um, I'm not a teacher. I'm just a humble engineer trying to do the best they can, right? With what they have, like most of us, right? So going back to the Oud project, right? So um, the so there's the sequence of steps that I have followed with the Oud project, right? And again, my engineering background, I think I've done it for so long that the process of how to go about these projects is part of my DNA. Uh, so to me, it's fairly natural flow. I hope to most of you that are watching this video, it may be or it may not be. So irrespective, it don't really matter, right? Everybody is unique. But in my process, I start with requirements. So first, I got to know what I want, right? Which is a difficult one, right? But once, and I'm always prepared that as I progress down a project, requirements will change. Hopefully, not significantly to completely derail the project, but it'll change somewhat. And I'm ready to adapt and tweak, wherever I need to. Then I go into a design, right? And some of those videos, and I haven't published everything that I've done. Um, but some of those aspects in terms of requirements and design, those are kind of the initial steps in this project. So now that I have a design, and again, design typically will go through some iterations, hopefully not too many, right? Then I get into at a high level, I need to understand how much this is going to cost me, right? Now, I've been fortunate enough that so if there's someone a complete beginner that are just starting out, you can get something like this done with a basic set of tools. I was fortunate enough since I've been making that I had a reasonable um, reasonable amount of tools already in my arsenal, right? And obviously, I had gaps in terms of specific woodworking. Initially, I thought I'm going to go all hand tools, but uh, as I proceeded with this project, I came to the conclusion that the hybrid approach is the best approach that's going to work for me. And if there's a beginner watching this video, I'm going to if there's any beginners that are interested in additional details on what tools I have and how to go about acquiring these tools, uh, uh, leave a comment and I'll try my best based on my availability. I'll try my best to respond to that. Not based on my availability, but I'll try my best to I'll try my utmost best to respond to any queries, anyone that is wanting more information. I would be more than happy to do that, right? So, the first, so Oud has different pieces, right? Right. And again, if you search online, and I'll see if I can publish some details on all different pieces, parts, and some pictures, right? But I started building that on the make side. I started with the bowl, which is one of the key uh, parts of the oud, right? So I started with the bowl. Now, one of the difficult things with, unlike let's say a guitar, for example, right? Um, the back of the guitar, traditional guitar, if you look at an acoustic, is flat, right? Oud is a pear-shaped. Uh, so oud's bowl is shaped like a pear. So what that means is that you have to have the ability to bend the wood to follow that contour, right? So that was the first thing that I attempted to do, right? Which involved setting up my bandsaw, and I've got an old Craftsman 12-inch from the 90s. Uh, it requires some care and feed, but it does all right. So I use that to resaw some rib blanks. I did it on softwood. So the wood that I used is spruce. Actually, it's construction grade, but when I resawed, and I can show a blank I got sitting here. Just excuse me one moment. Yeah, sorry about that. So this blank, right, or billet or whatever you want to call it, right? This is spruce. And I don't want to go into a lot of details because when you pick up wood from Home Depot, you don't know in that construction grade if you're going to end up with a pine, spruce, or fir, right? SPF. So S spruce, P pine, F fir. This for sure, I know it's spruce. For one, it's got a really fragrant, aromatic smell, right? And then the way the knots and uh, the way this wood is structured, and I'll share some additional details in a later video. And sometimes it's not that easy to distinguish. Um, so anyway, so I did cut the ribs, um, and I posted it in one of my videos, right? So it's not ribs, excuse me. These are just thin veneers, right? About 2 millimeters, a little over 2 millimeters. But this was my step one, right? That do I have the ability to cut these uh, using wood? And I selected spruce, right? I do have some ash that I've acquired, and I got some walnut. So my next step on this is based on the rib measurements and the dimensions, I'm going to cut ribs using those hardwoods, right? So with that part now behind me, right, the next uh, aspect of the project, I have to have the ability to do two things, right? So this is bandsaw cut, no matter, and I've got actually, I did get a 3 TPI resaw blade from a bandsaw, but even then, and I haven't used it yet. This is from a 7 TPI. Uh, but even with a 3 TPI, the surface is not going to be smooth, right? Right. So I have to have a way to smooth the surface. Now, something like this, right? Something as thin as this, um, if I had a drum sander, I could just run it through a drum sander, but drum sanders are expensive. Drum sanders cost anywhere from $900 to $1,000, right? I don't have that kind of money laying around. So my options that I'd been exploring was to go build me a drum sander, doable, fun project, right? But it's going to take time and effort to get it precise, because that drum has to be completely balanced, because this doesn't give you too much option on a 2 millimeter to have any variations, right? So that drum has to be um, set in a way that is completely precise, with a bed, uh, and completely balanced. So it's very doable. It's an exciting project, and I do plan to build one. But I was kind of debating whether I want to do it now, or I want to wait until at least I've got my Oud project underway to some extent. So the other option to smooth it and dimension it is using a block plane, right? So this is a World War II era plane. And again, I'm gonna go into some details on a different video, but my intent here on this video was just to kind of explain the kind of the thought process and the decision making on what the next steps are and how I'm going to go about doing that, right? So I think what I'm going to do is, for now, I'm going to put the drum sander on hold, building that drum sander on hold. And I am confident, based on my current skills, that I can set up that block plane that I just showed on the video and get some really precise smoothing done on these blanks. Okay. So now next, so after that smoothing aspect, right? I got to be able to bend the ribs, right? There are bending irons that are commercially available, but they're expensive. I mean, if you go search online for bending iron, they're used for violin making, for guitar making. They're expensive. I mean, they can run, $1,500, $200 north of that, right? So again, I don't have that kind of money to go buy me a bending iron. At some point, if I do, I may, but right now I don't. And I don't think I need to buy a bending iron. I'm going to make one. So to make a bending iron, let's talk about, so this video was specific to making a bending iron, right? So to make a bending iron, let's talk about some a few requirements. Most wood, right, will bend at a temperature around 350, 300, 350, 400 degrees Fahrenheit. Most wood would bend at those temperatures. And I've researched enough to know that estimate to be kind of correct, right? The challenge becomes what form are you going to use to bend? So you can have a form, right? If you think about it, you can have a form. Just give me 1 sec. Let me get something out here. Okay. All right. So you can. So this is a template of the for the ribs, right? And I haven't gone too much details on how this came about. In one of the videos, I'll post it. But if you think about it, if you have a form, so if this is the shape and this is the profile of the rib, if I can build a form, right? and follow this contour. So think about putting aluminum on top, right? All the surface is aluminum following this form. Then I can, and then there's a heat source underneath, right? So the surface temperature is what I said, 300, 350, 400. You probably don't even need that much. It depends on the type of wood you're using, right? But let's say, those are the temperatures that you're working with. If you have a heat source that raises that surface temperature to those levels, then this piece of wood, moist, you can just slowly start curving around this contour, right? Maybe even build that form so you can clamp it back and front, right? And leave it there overnight or what have you, right? And eventually the wood will should conform to that form, right? Uh, the challenge with that method, I don't want to say challenge, but the constraint, I want to say constraint, right? The constraint with that method is that then you're restricted to just one profile design. If you want to change the dimensions, you got to make a different form. Um, so if you know that you're going to stick to just one design, one dimension, and maybe this is the only oud or musical instrument that you're going to build, by all means, that form will serve you well, right? It will take longer to build, but it will serve you well, right? I wanted to go down a path where I'm not limited with that constraint, right? So the approach that I am planning to take to build my bending iron is just using a pipe, right? A pipe, right? Obviously, this is 18 inches. Yeah, I don't need 18 inches, right? I need about 6 inches, right? A heat source sealed from the base to whatever extent, sealed from the top, and this surface temperature I can easily get to, uh, I want to say 500 degrees Fahrenheit or north, depending on what heat source I'm using underneath here. This is 2 millimeter thick. Now let's talk about this pipe as well, right? And what options you have. Um, so the easiest option is if you're in the US, you walk into a Home Depot, you walk into a Lowe's, and you go pick you up a galvanized steel pipe that is used for gas applications, right? Not the ducts that are used for air. Those are too thin, and just with a little uh, force, right? Uh, they will crumble. So that's the easiest option, right? You can go pick up a galvanized steel pipe um, from Home Depot or Lowe's, right? And that's fairly inexpensive, relatively speaking, right? That's not the option I went with, right? And I'll give you my reason why. This is actually a exhaust tailpipe. It is not galvanized steel. It is aluminized steel, and there's a difference. So here's the difference, right? Galvanized steel, um the evaporation temperature, the temperature at which that uh, uh, zinc will evaporate, right, is about 350, around 350 to 400 degrees Fahrenheit, right? The temperature at which aluminum will evaporate is north of 900 degrees Fahrenheit. So if I'm building a pipe and let's say my heat source, I want to use instead of, you know, um, so I'm planning to use a incandescent bulb. That's what I'm planning to use, and I'll talk about it in a minute. But either a bulb or a heating filament or a fire in the hole approach, where I just light up my propane torch and heat this up, right? And then control the temperature through whatever means, right? This temperature on the surface can potentially exceed 500 degrees Fahrenheit, right? So I don't want to be sitting there worried that I am inhaling. So while I'm bending my ribs, I don't want to be sitting there worried that I'm inhaling zinc vapors, right? Which are highly toxic. So that's one of the reasons I opted for this. Now, this you would think uh, that in the US, you can get this fairly easily, right? Uh, but my experience has been a little different. I got this from Advanced Auto Parts. I paid about $11 for this 18-inch pipe. So this is a 3-inch diameter, right? And I paid about $11 for this, right? Galvanized steel is even less expensive, but like I said, you don't want to use galvanized steel, right? So either you go to Advanced Auto Part, pick something like this, right, and then cut it, and I'll talk about the cutting process as well, right? Or you can go to your local friendly muffler shop, um, have one of those good people uh, cut you an exhaust, right? That'll work. Take your dimensions with you. They're equipped with welding, so they can even weld a cap. In my scenario, um, this is just an aluminum cap, 3-inch, right? This I picked from Home Depot. I was initially planning to rig something, but this was inexpensive enough that I picked it, and this fits pretty snug right on top. So that's how I'm gonna seal this pipe, right? When I cut it, right? So exhaust muffler shops, Advanced Auto Parts online. You can get it online. Um, there are some folks that also use good old uh, this good old mug, right? Mug or thermos, right? Okay. Um, this is stainless steel. Most of these are stainless steel. You don't want to use this either. Looks amazing, right? So you have this, you put your heat source, boom, you already got a ready-made pipe. Stainless steel is not a good heat conductor, right? One. Second, most of these have an insulation. That's how they keep things uh, warm, cold. So for the heat to radiate from the inside, because your heat source is on the inside, radiate from the inside to the outside, unlikely that you're going to get the temperatures you need to get to, right? So that option, yes, I did consider it, but that option off the table, right? So let's go talk about cutting this pipe. And in a follow-up video, I'm gonna go into details on or show how I cut it, right? So let me just shift my camera over here. Right, I think it's still visible. I'm going to talk through a few methods that you can use to cut that pipe. Right? So, no matter It doesn't matter, right? It don't matter what method you use, right? Um, unless you do it on a day-to-day basis, cutting either metal pipes, steel pipes, or PVC pipes, right? You will not be able to cut straight, right? It is highly unlikely. So one approach, before I go into the approach taken, right, let me talk about the options that one has to cut. The trusted old angle grinder with cutoff wheels, metal, steel, stainless steel cutoff wheels, right? Very thin. This is obviously a pack, so there's about 10 in here, but extremely thin wheels on an angle grinder, right? Uh, just be careful with angle grinders, right? I've used enough to know that this thing will bite you. Even if you've taken all safety precautions, this will bite you. I've seen so many, uh, not only online, but you know, even in real life, right? Not that online is not real. That they remove the guard, right? Those are brave souls. They remove the guard, operate it with a single hand. I'm not going to go into all the details on an angle grinder safety. This thing is going at 11,000 RPM, right? So again, make sure if you're using angle grinder, make sure that the wheel or the cutoff wheel that you're using is rated higher. The mine is 1100. Yours may be different, but whatever the rating of your angle grinder is, that wheel rating has to be higher than the rating of the angle grinder. And do not remove the guard. Use two hands. Use protection, face shield, whatever's right. So that's option one. Maybe so. This is the easiest option because it's gonna go through this like butter, not like butter, but fairly easily, right? It's gonna be sparks. So work in a space where you don't have any flammables close by, right? Option two, you can use a trusted old seesaw, right? Which is a reciprocating saw. Use a proper blade. This is a bimetal blade. 14 TPI should do the job. This is just 2 millimeter thick. This should do the job, but make sure that again two hands and the shoe rests right against the piece that you're cutting, right? That's option two. And this is not a bad option either. Option two, right? Now, if you are cutting a lot of pipes, angle grinder, reciprocating, perfect. You're just cutting one pipe for now, right? So option three, and if you don't want to deal with sparks, and if you don't want to deal with or you may not even have a reciprocating saw or an angle grinder, right? The lowest cost option, trusted old hacksaw, right? With the proper blade. Again, with the proper blade, right? So if you run to Harbor Freight, for example, or most of these hardware stores, you're going to get something like this, an 18 TPI. Can it do the job? Yeah, maybe, but that's not what I would recommend. What I would recommend is get you a, and I think I'm going to put a link in the video description. Get you a 32 TPI bimetal. Again, I'm not going to go into all the details of what that bimetal is in this video, maybe in a later video, but important, get a 32 TPI bimetal blade, and this, it will take some work. It's not going to be too bad because this is not tool steel, right? This is uh, aluminized steel, so it is kind of considered mild steel. So it shouldn't be too bad, and that's what you can use. But one tip I'll give you, right? So don't just go measure 6 inches like on this exhaust. This is the end where I'm going to use the heat source, right? Because there's a slight, so this diameter is slightly larger than the rest of the pipe, right? Yours may be uh, different, maybe all the same diameter, but I'll give you a tip on how to go about cutting a straight line. If I can find what I'm looking for, which is, yeah, I think I have it here. So you may not have these. I have plenty of these, right? These are just worm clamps, good old worm clamps, right? Now, like I said, if you're doing it on a daily basis, right, cutting it straight, no, if you've got the skill, go ahead and do it. I've cut enough pipes, and I still struggle to get me a straight line. I can manage on PVC. Uh, Sometimes I've got to do 2 cuts, but the easiest way to do it is get you a worm clamp, right? Just a gear clamp. Mark your measurement, right? Tie your clamp right here, and this, right, on the edge. So wherever you want to cut, I don't know if you can see this, right? Wherever you want to cut, that edge will give a straight line, right? I hope you can see that, right? So the edge that is formed using this clamp will give you a, straight line against which you can run your hacksaw, and for that matter, even your reciprocating saw, right? So that's how you would cut uh, a, uh, a steel pipe, right? Just one comment I'll make on if you did decide to use an angle grinder, right? Make sure that you know uh, how to install your wheel, right? Okay. So these flanges have to be so these wheels I have, they're non-threaded, right? Typically on cutoff, you're not going to find a threaded, but make sure that these flanges, read your instruction manual, make sure these flanges are completely flush. Do not over tighten. Do not over tighten, right? There's a risk that you may damage the wheel. You don't want this thing spinning at 11,000 RPM, fragments of this coming at you on your neck or any part of your body or close to your body. Okay, so that's how you cut the steel pipe. Now let's talk about the heat source, right? I'm planning to use a good old incandescent bulb, right? These are not so I don't know when it was Joe Biden administration, they had a law passed. It's not illegal for these incandescent bulbs to be sold. I don't think it's illegal. I think it's more uh, more so that I don't know what it is. I don't think it's illegal, but it's more, preventing retailers and manufacturers from making this good old incandescent bulb, right? Okay, which whole different story on my perspective, but not going to go there. All right, these incandescent bulbs, the old-fashioned bulbs, right? They have a tungsten filament. You can see that filament, right? The way these work is this is 120 volts. If you're in a different part of the world, you may have a different voltage to 20, I think, right? In the US, North America, 120 volts, right? This is a 200 watt. I can get it for 500 watt as well. These are inexpensive. I got it online. I think I paid $2 or something for this bulb, right? I got a pair of two. This tungsten filament, the way these work, right? When electricity passes through this filament, it heats it up to almost 4,000 to 4,500 degrees Fahrenheit. It starts to glow and produces light, right? So basic law, energy conservation law, right? Energy cannot be created or destroyed. It can only be transformed from one form to another. Okay. So when that electricity passes, right? Again, the famous Ohm's law. I don't want to go into too much details there either in this video. But the point I'm trying to make is these bulbs are extremely inefficient, right? Because these are light bulbs. They're supposed to convert that electricity into light, but I think only 5% gets converted into light, and the rest gets converted into heat, right? So again, energy cannot be created, destroyed, just transforms. So that heat is what we can use to our advantage. You stick this bulb on the base of that pipe I showed you, right? And let it heat. Measure the outside surface temperature. Again, I've got a IR temperature gauge that I've used on engines and what have you that I can use if you don't have one. I don't know how much they cost these days, but you can get a sense. You can put water on the pipe, starts to boil, evaporate. That should be a good indication that it's going to try to start bending and see what it does, right? But if you can measure that surface temperature, that would be ideal. Then you know that your heat source is working and you're at the correct temperature, right? So if you do decide, so you can use either a light bulb, you can use a heating element. Don't go get the heating element off eBay. There's a lot of heater elements off eBay. They don't work, right? I've tried it, right? They don't work. I mean, they will just, they just stop working. So I don't know, made in China. Most things are made in China anyways, but I don't know what's the story with those heating elements, right? The other thing with, if you do decide to use the electric bulb, right? If you do decide to use the electric bulb, use a ceramic holder, right? So these are fairly standard. If you go do a search, right? This is a medium-sized threaded E26 base, right? Or I want to say this is E27, this bulb base, right? This is E26. So you may come across, if you're searching online, you may come across those uh, the reference to E26 or E27, but that's all it is. It's a standard bulb base with a standard old-fashioned incandescent bulb, right? Couple of things to be, so this is, I had this already laying around. This had a uh, switch which I removed, and I just got to solder 2 points so that I can um, then make sure that the contact is going to be there, right? Again, I'll put it in a separate video when I start building this. These, I don't know, these are several dollars. I don't even remember. This I'd laying around. I just picked it up. Um, one thing with this, right? These wires. This actually came off an old lamp, right? So what I got to do here is I'm going to change these wires. So I'm going to run a solder on those two contact points because this had a switch on the solder, which I don't need. These wires, if you do go build this, make sure you're getting heat resistant wires, right? This, I think, sitting on this is a 18 gauge. I'm gonna go heavier on this, right? So I'm probably gonna go. I don't think I need a 12 gauge. I'm gonna probably go 14 instead of an 18. So get you heat resistant wires and get you some good heat shrink, right? There's different types of heat shrinks. This is more like a fabric. Uh, you can get these in vinyl. You can get these in different materials, right? And I'll post it. So when I go get, so I don't have a heat resistant wire yet. When I go get mine, I'll put a link in the description, right? Make sure, because this where it's going to be sitting, because that pipe is going to be covering this, and the way my design is, you can have a different design. You can have it open from the back, so there's going to be less heat. But in my design, I'm gonna make it sit on a round base, and then that round base is going to sit on a square or a rectangle, which then I can I can clamp it in my vise, right? And I'll share some additional info there. But again, key points here: if you're going down the bulb path, use a ceramic, not a plastic. Plastic will melt at those temperatures. Plastic will melt. Use a ceramic, heat resistant wires, good heat shrink, and you should be good to go. One other piece you will need is a rheostat, right? You can either build this, right, or you can go purchase it, right? I think these are, uh, you can find these for 6, 7, $8, right, in the US, either from online or from Home Depot or Lowe's. I had this from a different project and I'm just using it now. One thing to an important thing, right? And hopefully in my next video, I will put details. Um, but one important thing on how you're going to wire the rheostat, right? You're not going hot to neutral. Oh, before I even go there, these need a ground, right? These need a ground. They don't have a ground, right? So where do you get the ground, right? So that steel pipe I showed you. So when you build this circuit, right, you have a hot. So from wherever you're running your wires from, right, uh, hot, neutral, and a ground. You need a ground. I would highly recommend you have a ground. You ground that pipe, right? You ground that pipe. So that gives a return path uh, to the current in the event uh, that something goes wrong, right? You don't want to be touching that pipe and that pipe is live, right? So do run a ground from the metal pipe, and I truly hope I make that video where I show the entire build process and how I go about doing it. But if you go do this, if you watch this video and want to go do this before I get to it, I don't even know how many people watch my videos, to be honest, right, with whoever is watching, right? But if you do watch this online and if you say, okay, I'm gonna go do this, remember, run a ground, right? Run a ground from that pipe uh, into your return circuit, right? On the rheostat, this is just like a switch. Remember that it's just that it controls the current. It's not a potentiometer. So it's not controlling the voltage, or it's not regulating the voltage. This is a rheostat. So it controls the current flow into that bulb, right? Right. So the way you're going to wire this rheostat is you are not going between hot and neutral, right? All you're doing is your hot coming from the wall, right? Your hot coming from the wall, boom, through the rheostat into the hot on this. That's all you're doing. So this rheostat just goes in series between what you have coming upstream from the wall, through the rheostat, to the socket, to the bulb. That's how you're gonna control the flow of current going into that bulb. So if you want that because let's say you're working, you got that pipe sitting at 500 degrees Fahrenheit on the surface. You do want the ability to reduce the wattage, and then also, let's say this 200 watt don't heat it enough. I don't know, I've got to build it and test it to see if this doesn't do the job. I'm gonna switch it with a 500 watt, right? 500 watt is gonna fit in that pipe, except that 500 watt is I think it's a little longer than this. And I'll post dimensions. So when, again, I didn't mention this earlier, but when you cut that pipe, make sure you leave just a little room on top, so that instead of this, if you want to go 500 watt bulb, you can do that. If you're going a heat element, those are really tiny. You can even use a soldering iron heat element, which may work out pretty good as well, right? So this soldering iron, for example, right? And I haven't looked at, actually I should. I haven't looked at online, but don't go get the junk off eBay for the heating elements. But the soldering iron heating elements, right? That may be another viable option. I honestly think bulb is gonna do it, but if it don't, then all right. So this is going all the way to what is it? 450 degrees Celsius, 450 degrees Celsius, right? On the tip, maybe on the tip. I haven't measured it with my IR temperature gauge, but so this is another option for you. Point being that, as you think through these requirements, think through what you're going to use as a heating element, and then I think out of the options for the heating element, fire in the hole, which is just a flame going straight to that pipe, and or bulb. I think the bulb is occupying the most space in that pipe. So if you design it with bulb in mind, and later you want to change it to a heating element, or even run a flame through, I think you should be all right. Okay. So I'm going to wrap up this video. I don't even know how long it's been. But I'm going to wrap up this video, and then I'm going to continue on the next one when I post later. Be safe. Respect to everybody. Be safe.